Okay, so we're doing the C4 Edexcel June 16 paper. I've already written the binomial formula which we're going to be using. This is actually on the C2 page of in the formula book. Although this particular form of it is seldom used in C2 these days. It's because this is actually applying to all values of n, whereas the NCR version, which is also in the C2 formula, applies only for n being positive integers. It is possible to tweak that for this question, but I would not advise it. I would use this form of the binomial for all general cases where n is not a positive integer, as it isn't here. N is -3 here. Right, so let's get on with it. We have the 2 plus 5x to the power of -3 is equal to 2, 1 plus 5x over 2 to -3, except it isn't, of course, and this was a common mistake that many of my students made today. It's wrong here. We need to put a -3 because the -3 is the power of the whole thing. So when we're taking 2 out, we need to, as a factor, we need that to be 2 to the power -3 as well. Well, 2 to the power -3 is 1 over 8. And then we have 1 plus 5 over 2 -3. So now it is a case of just using this binomial formula with n equals to -3 and replacing x here with 5 over 2x. Okay. So, let's get on with it. That's equal to 1 over 8 times by 1 plus nx, n is -3, but x is being replaced with 5 over 2x, plus n minus 1, -3, -3 take away 1 is -4, over 2 factorial, 5 over 2x squared, and we need to go up to the next term as well. That's -3 times -4 times -5 over 3 factorial, 3 times 2 times 1, 5 over 2x cubed. Let me just change the factorial here to 2 times 1. It is factorial, but that means I can look for common factors easier. Okay, so I'm not going to use a calculator for this question, although of course you can in C4. I'm just going to do a bit of cancelling to avoid having to use the calculator too much. Well, no cancelling can go on in the first term, but there's plenty that can happen here. Here we've got a 2 squared there, because that can cancel with the 4. Okay. That looks okay. That's probably about as much as I can do. Now here, I've got a few things here. I've got 4 on top. I've got the 3 can cancel, obviously. I've got lots of 5s on top, so they don't cancel. I could cancel well, I've got to be careful here because this is 2 cubes. So let's keep it easy and cancel that 2 with a 2 there. And then what's going to happen is I'm going to end up with a 4 on the bottom here because I've got an 8 on the bottom cancelling with the 2. So that should enable me to work out the thing. So we have 1 over 8, 1 -3 times 5 over 2 is -15 over 2x. Now I've done this cancelling here, I can see I've got 25 and I've got 3, and I've got a 2 on the bottom, so that is, and the negatives cancel, so that's plus 75 over 2x squared. The next one I've got 3 negatives, so it will be negative, and I have, as I said before, I've got the 4 lots of 5 on the top, 5 times 5 times 5 times 5, which is 625. And on the bottom, as I said, I would have had, I've got an 8 here, but I've got a 2 here, so that comes to 4x cubed Now let's multiply out by the 1 over 8, because it wants each term written out term by term. That's 1 over 8 minus 15 over 16x plus 75 over 16x squared minus 625 over 32x cubed. And that's the only terms we need. Okay, that's question 1. Let's look at question 2. Right, so question 2 is part A starts off with the trapezium rule. I've already filled in the table of values here for the function. We're finding the area under this, and we've got a function y equals x squared ln x. And one simple mark is to put 0.6595 in there to get the other value there. Can't imagine how many people wouldn't have been able to do that in the C4 exam. Probably no one. So I've put that in, and I've also written down the formula that we have, which as written in the C2 formulae here. It's written in the C2 formulae. I do see cases, my trapezium rule isn't normally something that students slip up with, certainly not in C4, but where they do, it's normally misusing this formula here, because the number of ordinates is always one more than the number of strips. So for example, in this case, we've got 1, 2, 3, 4, 5, 6 ordinates, which means there's 5 strips. It's been split up into, can't draw it here, but it's been split up into 1, 2, 3, 4, 5 strips. And so we can see there's 1, 2, 3, 4, 5, 6 ordinates. So students do occasionally make that mistake, but it would be silly to use that rule here anyway, because we can see that h is 0.2. Yeah, it's the difference between these here. H is 0.2. If you were to use it, it would be unnecessary, but you would just be saying 2. H is 2, take away 1, the two ends, divide by the number of strips, which is 5, which is 0.2. Totally unneeded, but just trying to perhaps highlight the one area that students sometimes make a mistake with the trapezium rule. Now, okay, so let's just do it. Let's put this in. So that gives us the area is approximately equal to, as I say, h is equal to 0.2. So that's 0.2 over 2 using this formula. And as I've annotated this, the y0 and yn are the first ordinate and the last ordinate. So that's 0 plus 2.7726 plus 2 times the sum of the middle ordinates. So that's all of these added up together. So that's 0.2625 plus 0.6595 plus 1.2032, just make a bit more space here, and plus 1.944. And it's just a case of working that out. 3 decimal places, that comes to 1.083. Okay, so that's the first bit, A and B done, the trapezium rule. Now we've got to do a bit of exact integration now. So we're basically integrating this expression between the limits 2 and 1. So we want to find x squared ln x dx between 2 and 1. Right, now this is a case where integration by parts is used. I'll just write up the integration by parts formula. There it is. Now, in these cases where we have a ln, we would let the u bit, be equal to the ln. Any expression where we're using integration by parts with a ln will normally have some power of x or some algebraic term with it, and that's the other bit we let be equal to dv by dx. If that feels a bit unusual, it's just quite a well-known thing. If that were x squared sine x, for example, we'd do the other way around. We would let the u bit be equal to the x squared. Anyway, so we've got u is equal to ln x, so that gives us du by dx equal to 1 over x. And then we need to work out the v, which we're going to put in our by parts formula. That's equal to v, which is a third x cubed. Now I know we've got limits here, but I do tend to just, when we're using integration by parts, put the limits in afterwards, do it indefinitely, using indefinitely first, and then put the limits in when you find done it all and simplified. So we have the integral of x squared ln x dx equals uv. So uv, that is 1/3 of ln x and x cubed. I'd probably be better off putting the x cubed before to avoid confusion there, so let's do that. 1/3 x cubed ln x. Take away the integral of v du by dx, so that's 1/3 x cubed du by dx, which is 1 over x dx. Now we really want to be simplifying that now before we integrate. Take away, that's 1/3 x squared dx. Now this is just a normal power integration. Add 1 to the power and divide by that number. So that gives us 1/3 x cubed ln x. Adding 1 to the 2 gives you 3, divided by that number gives me 1 over 9 x cubed. We can put a plus c here, but we've got definite limits anyway, which we can now go on to actually input. So now putting in the limits, I do normally prefer to do it this way rather than try. Sometimes with more advanced work, we need to put the limits in to, for example, FP3 reduction formula, we need to put the limits in straight away. But here, it's just as well to put them in when we've done the whole thing. So we've got 2 to 1 x squared ln x. 1/3 x cubed ln x, take away 1 over 9 x cubed between the limits 2 and 1. So that gives me 1/3 2 cubed ln 2, take away 1 over 9 times 2 cubed. That's put in the 2 number in. Now taking away the value with 1, 1/3 1 cubed ln 1, take away 1 over 9 times 1 cubed. I prefer not to use a calculator here. This is 0 because ln of 1 is 0. This is 8 over 3 here. This here is 8 over 3 as well. So we have 8 over 3 ln 2, take away 8 over 3, it's 8 over 9 of course, and this is plus 1 over 9, which comes to 8/3 ln 2 plus 7 over 9, minus 7 over 9. There we go. Let's have a look at the next question. Okay, so we have implicit differentiation. We've got a product here with x squareds and y's. Some people like to write this out, but I'm not going to. I'm not saying I'm going to encourage you to write out the u equals to 2x squared and v equals to y for each product. We should be able to just smash this really. U equals 2x squared, differentiate. We're going to use a product rule on this bit. Differentiating 2x squared, I get 4x. Now I need to times that by y. And then I need to differentiate y, which is dy by dx. differentiate y with respect to x, I get dy by dx, and then times that by the 2x squared. So that's that bit differentiated. 2 differentiated is obviously 2x differentiated, obviously just 2. 4y differentiated is 4 dy by dx. We've done those 3 terms. Now finally this one, slightly probably the most problematic. Cos differentiates to minus sine. So minus cos differentiates to positive sine. But a few things first. The pi we need to times by pi. So that there is what d by dy of this expression is. If I differentiated it with respect to y, but I'm differentiating with respect to x, so using the chain rule, times by dy by dx. Then the 17 differentiate comes to 0. So I can put out as a factor, factorise the thing, 2x squared plus 4 plus pi sine pi y dy by dx equals to, taking the other terms over to the other side, minus 4xy minus 2. So that gives me dy by dx equals to minus 4xy minus 2 all over 2x squared plus 4 plus pi sine pi y. Right, so now it's just a matter of, that's part A done, because it wanted an expression for dy by dx. Now what it's saying for part B is that we've got a 0.3 on there, and it's a normal, and it wants us to work out where that normal crosses the x-axis. Right, so first of all we need to find or be able to get an expression for the normal, equation of that normal, which involves getting the gradient. So let's just work out at P dy by dx equals to minus 4xy, so it's minus 4 times by x, which is 3 times by a half, take away 2, all over 2 times 3 squared plus 4 plus pi sine pi, and y is equal to a half, so that's pi over 2. Like that. So, right, and so the top bit, that's minus 12 times by a half, so that's minus 6 minus 2, so the top bit is minus 8. And then on the bottom we've got 9 times 2, which is 18, plus 4, which is 22. And then this bit here, sine pi by 2 is equal to 1. I haven't used a calculator. I think I'm quicker than, I'm probably more accurate than actually trying to put this expression in the calculator. Right, so now that's the tangent. So the gradient of the normal is the negative reciprocal of that. So that equals to 22 plus pi and over 8, and it's now no longer negative. Right, so the next bit is to find where this normal crosses the x-axis. So if I write y minus y1 equals mx minus x1, well, the equation is y, I'll just write this for a moment, y minus y1, and y1 is equal to a half, is equal to m, which is equal to this expression I have here, so it's 22 plus pi over 8, x take away 3. But we're not really interested in the equation itself. We want to know where it crosses, where the normal with this equation crosses the x-axis, so why don't I just replace that with 0, or I don't even have to do that because we want that to be where it crosses, and I could just call this xa to make it clear I'm interested in the x coordinate of A. Let's write this now, the answer over here. I'm going to times through by 8, now minus half times 8 is minus 4, and divide through by 22 plus pi, so that's 22 plus pi, that gets rid of this and puts it over here. That gives me xa minus 3. So the x coordinate of A is equal to 3 plus 3 minus 4 over 22 plus pi. And it wants it in this form, so we can't leave it like that. So that's 66 plus 3 pi over 22 plus pi, putting over a common denominator, minus 4 over 22 plus pi. So that comes to 62 plus 3 pi over 22 plus pi. Okay, let's have a look at question 4. Question 4 is a practical differential equation, fairly standard model actually, model of exponential decay. Looking for the boundaries for this paper were actually quite high. I think it was 65, I think, for an A, or 70 for an A star. And I suppose I want to put it down to one or two things. There was no really difficult, some of these questions can sometimes be difficult, but not this one. And I think it was done quite well in the actual exam in 2016. It says solve this, and it wants you to make sure that you write through every step, so we better do that. It has specifically said that. If we separate the variables, we've only got the x here, which can come down, divide by x on both sides. So we have 1 over x dx equals to, and we'll have minus 5 over 2 dt. Right, so we can basically separate it out like that. That gives me ln x is equal to minus 5 over 2 t plus c, and you would be penalised here for not writing the c. Now, we don't really want to see a modulus sign here, by the way, because we know x is positive, so leave that out. And then we're told when x equals 60, t equals 0. So that gives me ln 60 is equal to c. So I can now go back and put that back in. So I have ln x equals minus 5 over 2 plus ln 60. I can take x out now, e the whole lot of this, 5 over 2t, so I can do e for the whole lot of this, so it's e to the minus 5 over 2t plus ln 60. That actually comes to 60 e to the minus 5 over 2t, because we're using the rules of indices here, because that there is e to the minus 5 over 2t times by e to the ln 60, and e to the ln 60 is a self-inverse, and that equals to 60. So that's part A done. Then part B, it says find the time taken for the mass to go from 60. Well, it starts at 60, so no difficulty there, to 20. So we're just basically putting 20 in this formula here, into this formula, and finding the corresponding value of t. So we have 20 equals 60 e to the minus 5 over 2 t. So we have 20 over 60 equals e to the minus 5 over 2t, which is equal to a third. If I take the reciprocal of each of those and kind of swap it around a bit, that gives me that. Okay, ln 3. So that then, I can then ln both sides, so I'll get 5 over 2t is equal to ln 3. So t is equal to 2/5 of ln 3, which in days is 0.43944. That's in days. But it wants the time in minutes. So time in minutes is going to be equal to that number, which convert into hours would be times them by 24, and then convert into minutes, that would be times by 60, which when I work that out to the nearest minute, 633 minutes. Okay, so that's it. You didn't have to convert to hours and minutes. It's fine to leave like that. So as I say, that was pretty straightforward for as those questions go. So let's have a look at the next question, question 5. So question 5 is parametric equation question. First bit is to find an expression for dy by dx at a given point P, which we're given there. So it's just a case of finding dy by dx. Now I tend to like to just go straight to dy by dt over dx by dt. It's just a rearrangement of the chain rule, basically. Now, dy by dt, differentiating this, that is equal to 10, because of the 2 here, we're times it by 2, 10 the square root of 3 cos 2t. And then differentiating this is 4 sec squared t. That comes to this, simplifying down a little bit. It's hardly worth the effort, but I'm going to do it anyway. Cos 2t. I could actually write the sec squared t as a cos squared t on the top there. Don't have to, but I'm going to. So then we need to just find a appropriate value of t. I'm going to use the x-coordinate because it looks like the easiest. So we have at P, we want to find the value of the parameter. So we have 4 the square root of 3 is equal to 4 tan t. So that gives me tan t equals to the square root of 3. So inverse tan of that, we should know that, is pi over 3. So we can now put that into this expression. So at dy by dx at P, again, equals to 5 the square root of 3 over 2 cos 2 pi by 3 times by cos squared t, so that's cos squared pi by 3. Now 5 the square root of 3 over 2 cos 2 pi by 3 is equal to minus a half. Cos pi by 3 is equal to plus a half, so that's plus a half squared. So that's going to come to minus 5 the square root of 3 over 16. So that's that question done. And then part B, it says the point Q lies on a curve where dy by dx is 0. So we basically want this point here, find the exact coordinates of it. Well, we can look for when dy by dx is equal to 0. And the way I've written it is 5 the square root of 3 over 2 cos 2t cos squared t equals 0. Well, now the cos squared t equals to 0 is not going to apply here, because cos t is equal to 0 when it's pi by 2, and that's outside our range. It's going off here somewhere at that point, so that's not appropriate. So pi by 2 isn't part of the range, so we're looking at this one only, really. So we've got cos 2t equals to 0. So that gives me 2t equals pi by 2. So t equals pi by 4. So I can now put those into the parametric equation. X equals 4 tan pi by 4. Tan pi by 4 is just 1, so that's 4. And y equals to 5 the square root of 3 sine pi by 2. This is all working out quite nicely. Sine pi by 2 is equal to 1, so that's 5 the square root of 3. So we have the point Q is 4 and 5 the square root of 3. Okay, not bad. Question 5 done. Let's have a look at 6 now. Okay, so integration again. So let's get on with it. Part 1 and 2 don't seem connected at all, but then part 2 itself is split into part A and B. So this is going to be by partial fractions. It's not told us by partial fractions, but it clearly is by partial fractions because of the form of the thing with the 2 factors on the bottom. I'm going to use something called the cover-up method, which basically means I don't make too much of a meal of the partial fraction. Some of you may not have seen the cover-up method, but I think it does save a bit of time, and it is perfectly, especially in a question where it's not actually asked you to express in partial fractions, where you use it as part of something else. Perfectly legit way of doing it. Okay, so I'll try and explain how this works. We know that it's going to be split into 2 fractions with y and 3y plus 2 as the denominator, dy. Okay, instead of writing it all out, this is how I do it. As I say, you might have seen it, where you see it, it's probably an older textbook, and it was called the cover-up method. So the way we look at it is that to look at what's going to go on in here, the number that goes on here, we basically input the value which would make this factor equal to 0, which is, in this case, it's y equals to 0. We cover up the ones, cover up here, we cover that bit up, and we put 0 into what's left. So this factor here is equal to 0 when y is 0, so we put y equals to 0 in here. Now y equals to 0 in there would be minus 4, because this bit would be 0, over 2, because this would be 0 as well. So it's minus 4 over 2, which is minus 2. So that gives us this number here as minus 2 on top here. Okay, so that's that factor done. So now for the other one, I need to be putting in the number when this factor is 0. And that's equal to 0 when y equals to, a little bit more problematic I suppose, but not too much, y equals to minus 2/3. When y equals minus 2/3, this bit is equal to 0. And I cover up this bit, and I input the number minus 2/3 in there. I might write it out this time. 3 times minus 2/3 is minus 2, minus 4 over minus 2/3. So that's minus 6 over minus 2/3, which is 18 over 2, which is 9. Okay, so that was using the cover-up method. Obviously, if I was doing it, I would do it. It would have been done by now. Let's change the colour back to blue. When I do, okay, some of you may have found that useful, some not. But when I do this, one thing I tend to like to do is do a quick scan to see if this multiplies out and does give this. And I can see that I'm going to get if I had to put over a common denominator, I'd get a minus 6y minus 4 there, which would give me the minus 6y minus 4, and it would have plus 9y here, which would give me what I want. So I can see it's correct, so it is right, and it saved a bit of time. I say I've talked through it, but I think it does save time if you can do it that way. Right, now this is all pretty straightforward. Now we can put in, we can just integrate that, so that's equal to minus 2 ln y plus 9 over 3, because it's 3 there, ln 3y plus 2. It's told us that y is greater than 0, so please, I've not looked at the mark scheme carefully enough, but we do not want to see a modular sign, plus c. And I think we better write that out. It doesn't need, we could combine these in one log, but it won't matter if we don't, so I'm not going to. Okay, second part of this is an integration by substitution. It's given us a substitution, which it would do normally with something not obvious. So we've got part A. Let's do the differentiating bit. We're changing so that we can change a variable. We can say that dx by d theta is equal to 8 by the chain rule sine theta cos theta. Basically, I've times through by the 2, the 4, and taken 1 off the power, so that's sine to the power 1. But then I've had to differentiate by the sine theta, which gives me the cos theta. So that's chain rule. So I can separate the variables. Dx, the dx operator, I can change with the 8 sine theta cos theta d theta. Right, so now under limits, let's deal with the limits as well, because I need to change those two, because they show that, so we need to be clear. When x is 0, theta is also 0, and when x is equal to 3, we can say that sine squared theta is equal to 3/4. So sine theta is square root of 3 over 2. So that is equal to pi over 3, because sine of pi over 3 is square root of 3 over 2. Okay, so now we're ready to actually just put this in, and hopefully it breaks down to something of this form. So that means that the integral of 3 to 0 of the square root of x over 4 minus x dx is equal to the integral, square root sign's coming from 3 0, the square root of x, which is 4 sine squared theta, over 4 minus 4 sine squared theta, and then I'm going to replace with the dx operator, which is 8 sine theta cos theta d theta. Right, okay, that equals, I've not changed the limits, have I? Pi by 3 here. So that equals pi by 3 to 0 of the square root of 4 sine squared theta. At the bottom we really ought to recognise that that's 4 cos squared theta, because 1 minus sine squared theta is clearly cos squared theta. So that we should recognise that without too much fuss. as 4 cos squared theta. I say it should. Many students don't make a right meal of it by replacing this with 1 minus sine squared and 1 minus cos squared and what have you. Oh, after waffling on, I forgot to actually finish the expression. 8 sine theta cos theta d theta. So this bit here, you might think, oh, I'm going to change it to tan, but why would you? We want to get it down to that, so it's certainly not something we want to do. So that's equal to the 4 cancels, that's equal to pi over 3 to 0 sine theta over cos theta, 8 sine theta cos theta d theta. So the cos theta cancels, so that equals to 8 sine squared theta d theta, which is what we're asked to prove, where lambda is equal to 8 in the expression we had there. Okay, so that's that bit, and now it says hence work out the integral in that form, a pi over 8. So now it's a case, it is putting us through our paces with integration. Integrating sine squared theta or cos squared theta, we use the double angle formulae. We note that cos of 2 theta is equal to 1 minus 2 sine squared theta. So that tells us that sine squared theta, rearranging that, comes to a half of 1 minus cos 2 theta. Okay, so that means that, so that's what we're dealing with. So let's just go back to the question. We've got 3 naught x 4 minus x dx equals 8 times by pi by 3 to 0 of sine squared theta d theta. And now that's equal to, now we've got half of these, so we might as well just half that expression, half the 8 there. So we get 4 pi by 3 to 0 of 1 minus cos 2 theta d theta. So that equals to 4, and this integrate, the one integrated is clearly theta. Cos 2 theta integrated is a half sine 2 theta from pi by 3 to 0. The 0 one will obviously work out to be 0 here, so that's 4 times the 0 limit. Putting 0 for theta is obviously 0, and sine 0 is 0, so we could say that it's just replacing theta with pi over 3, take away half sine 2 pi over 3, and as I just said, that's 0. This other bit, I don't bother that. What's the point? So that sine 2 pi by 3 is equal to square root of 3 over 2. So that's 4 pi by 3, take away a half, square root of 3 over 2, which is the square root of 3 over 4. Let's multiply out both because it does want it in this form. So multiply that out, it's 4 pi over 3, take away the square root of 3. Okay, that's question 6 done. Let's look at question 7. So it's more integration for question 7. There's always going to be a lot of integration on C4. A couple of marks, reverse chain rule situation here with this. So this is just using the adding 1 to the power rule that rule there. So we add 1 to the power, that's 2x minus 1 to the power of 5 over 2. Divide by that number, divide by 5 over 2, is the same as times it by 2 over 5. But we need to also times by half of that, the reciprocal of that number there, reverse chain rule basically, plus a constant. The 2 cancel, so that's 1/5 of 2x minus 1 to the 5 over 2 plus c. Right, so then we've got a volume question, a volume of revolution question. But before we get there, it says find the value of k here. So that's just a case of putting y as 8 in here and working with that. So let's do that first. So y equals 8. So we have 8 is equal to 2x minus 1 to the 3/4. That means that undoing this, that means that 8, taking the 4th root of both sides and then cubing, you're going to get 8 to the 4 over 3 equals to 2x minus 1. Now 8 to the 4 over 3, the cube root of 8 is 2, so that's 16 is equal to 2x minus 1. Bringing the 1 over, we get 2x equals to 17, x equals 17 over 2. Right, okay, so then onto the volume questions. Make a bit of space first. So we've got a volume of revolution question. A little bit of a twist on it. It shouldn't be too bad, but clearly if we wanted to find what this volume was rotated about the x-axis, that would be between the limits, because this number here is 17 over 2 and this number here is 8, so that would just be equal to 17 over 2 a half, because the formula for a volume of revolution is pi y squared dx between the limits. So our equation is now this, so that's 2x minus 1 to the 3/4 squared, so that's 3 over 2 dx. Now that would be equal to, well, before I work that out, just to make it clear, that's not going to be the s that we want, but what we're going to do, imagine you had the whole of this shape rotated, the whole lot of this rotated, then you'd have a cylinder. If you rotated the whole rectangle here around the x-axis, you'd get a cylinder. So we're going to take that volume we're about to find now away from the volume of the cylinder, which should easily be able to work out. So we can call that V, I suppose, just to make it clear that we're working that out. So the volume V. Right, now we've done the integration already. So we've done the integration in part A. So that's equal to pi from 17 over 2. Oh, I said we've done it. Now I'm going to write it in. So that's pi times 1/5 of 2x minus 1 to the 5 over 2 between the limits 17 over 2 and a half. Right, well that's pi times by 1/5 of 2x minus 1, that's 16 to the power of 5 over 2. Take away 1/5, and the bit is 0 to the power of 5 over 2, which is obviously 0. Now 16 to the power of 5 over 2, well the square root of 16 is 4, the 5th root of 4 is 1024, so that's 1024 pi over 5. But as I said, that's this volume here rotated, the volume I've called V. Now let's work out the volume of the cylinder. Well, the radius of this cylinder, because that will be the thing that's rotated, will be equal to 8. We know it's pi r squared h. So the radius is 8, and the height of this cylinder will be 17 over 2. So that's equal to pi times by r squared, so that's 8 squared times by 17 over 2. So that's equal to 544 pi. So that gives us S, volume S, rotated, because S was described as an area. So anyway, volume of S rotated is the difference between these two. Obviously the cylinder is the bigger thing. That's 544 pi. Take away 1024 pi over 5. Now 544 take away 1024 divide 5 is 1696 over 5 pi. And that's question 7 done. Let's have a look at the final question. The final question is a vectors question, and normally the first few marks of a vectors question come out very easily, and typically the last few are much more difficult. We've given an equation of a line L1 here, and it says point A corresponds to the value of mu equals 1. So we're just putting 1 into there. So the point A has coordinate. If we put 1 in there, 8 take away 5, that's 3. Put 1 plus 1 times 4, which is 5. And 1 in there, minus 3 plus 3 is 0. So that's nice and easy. Part B, also pretty straightforward. It says the point P has this coordinate, but it's going in the same direction as this. Well, the thing that determines the direction is this thing. That's called the direction vector there. So we can use that as the same direction vector for the line L2. So we can just say L2 is equal to, the equation is R equals to a point on the line, which we are given, 152, plus lambda, because we've got a mu here, so might as well use lambda this time. Lambda times by the direction vector of this thing, which is minus 543. Right, okay, so then that's the first few marks relatively easily got. Now it says find the exact value of the distance AP. Well, let's work out what the vector AP is. The vector AP is the same as the vector OP take away the vector OA, and the vector OP of course is 152. And the vector OA, A is this point here, so let's take away 3, 5, 0. So that makes up minus 2, 0, 2. So the distance from A to P is just the direction of that, the modulus, the length of that vector. So that's just minus 2 squared plus 0 squared plus 2 squared. That's the square root of 8, which breaks down to the formula we want, which is 2, the square root of 2. Again, not difficult so far, it's just the more difficult bits are yet to come. Okay, so question D is to find the acute angle between AP, we've got two lines, L1 and L2. A is some point on L1 and P is some point on L2, and it wants the acute angle here. Right, so if it wants the acute angle, the cosine of it needs to be positive. So if my dot product comes out negative here, I'll change the sign of it. But basically we can talk about cos theta being the dot product of AP dotted with the direction vector that we have for the line, which is minus 5, 4, 3. Over the magnitude of these two vectors. Well, we already know that this one, the magnitude of AP is 2 the square root of 2, so we don't need to fuss with that one anymore, but you can do it, work it out again if you want. Saves time to just pull it down from the question from before. And then this one is 5 squared, notice I've just dropped the negative, 4 squared plus 4 squared plus 3 squared. So let's work out the top bit first. Let's write some of this out. So AP, just to remind us, is minus 2, 0, 2. So the dot product is minus 2 times minus 5 plus 0 times 4 plus 2 times 3, all over the magnitude of these two is 2 the square root of 2 times by 25 plus 16 plus 9. Right, now the top bit now works out to be, that's 10 and that's 6, so that's 16. And the bottom bit is 2 the square root of 2 the square root of 50. Now these two bits together makes the square root of 100, which is 10. So we've got 20 on the bottom. I haven't used a calculator, so I'm quite proud of myself. Related to use one, of course, but sometimes if you can hold the numbers in your head better, it'll be quicker. So that's 4 over 5. And that's the answer to part D. Notice I just marked a few of these because we used it as a mark in my college. I've just marked a few, and some use PA. It's not a problem because some people might say, well, shouldn't it be that one? But the fact was, it talked about the acute angle between the line and the vector. So I would just make a modulus of that sign anyway. So any negative should be dropped, otherwise you'll lose a mark because it wants an acute angle. Okay. Now part E. It says AP lies on, so E lies on line L2, and it's got the same distance, it's got the same magnitude of AP. Right, just a reminder, we know AP is 2 the square root of 2. So we've got the point E lying on to L2, say there, such it's the same magnitude. There. Notice it could also be there, because that would also be 2 the square root of 2, which leads into our question that we have. The next question, or there. These are 2 possible triangles, and they'll both have the same area. So both of these have 2 the square root of 2. As they're 2 adjacent sides, and we know the angle in between. Theta, we know the angle, we know that cos theta is 4 over 5. So here we go. We know the area is a half the 2 adjacent. I'm basically using half AB sine C, if you're wondering. I'm using that formula. The 2 adjacent sides, which is half 2 the square root of 2 times 2 the square root of 2 times sine theta. Now we should see from a 3, 4, 5 triangle, hopefully this is fairly obvious now, that sine theta is 3 over 5. So I haven't used a calculator. Some people might have done anyway, but sometimes wish they didn't allow calculators on all of the pure papers. But anyway, 2 to the square root of 2, 2 to the square root of 2, 3/5. So 2 cancels here, and we've got square root of 2, so we end up with 4 on the top times by the 3, which is 12 over 5, or 2.4. Okay, so we just got one question, we've got one final bit to do, but it's 5 marks. I'm going to redraw this diagram here for part F. We basically, what we're looking for is, we've got the point P here, and we've got the two possible points for E. You can call it E dash here, whatever. The 2 possible points for E, and we know that this length here is 2 to the square root of 2, or this length here is 2 to the square root of 2. Right, so we know the direction of this vector. We know that the vector PE is some multiple of the direction vector. Let me just change colour. So let's write that again. PE is some multiple, lambda, say, times by the direction vector of this line. And we can go all the way back to these. Both lines, thankfully, go in the same direction, so we're not going to pull down something incorrect if we look at the direction vector of L2 or L1, if we should do so. It's minus 5, 4, 3. Okay, but we need the length of PE, so in other words, the modulus of it, to be equal to 2 to the square root of 2. So that's right, this is minus 5 lambda, 4 lambda, and 3 lambda. So we can say that PE, modulus of PE is equal to the square root of minus 5 lambda squared plus 4 lambda squared plus 3 lambda squared, and that equals to 2 to the square root of 2. And squaring of both sides of that, we're going to get, and then working out these things inside, we get 25 lambda squared plus 16 lambda squared plus 9 lambda squared. And don't forget to square this as well, that's 8. So that gives me 50 lambda squared equals 8. Lambda squared equals to 4 over 25. So this is what's going to give me my 2 possible values, plus or minus 2 over 5 are the 2 possible values. That might be the positive one, say. So I've chosen them arbitrarily, of course, and the other one will be the negative one. So now all we need to do is go back to the equation of L2. I've just got it at the top of my screen here. This equation is this, 152, so let's write that up again. 152 plus lambda times by minus 5, 4, 3. So when lambda equals to positive 2/5, I've got E equals to, now putting 2/5 in here, minus 5 times 2/5 gives me minus 2, so that will be minus 1. 4 times 2/5 is 8/5 plus 5, that gives me 33 over 5. Let's write that properly. Then 2/5 times 3, that's 6 over 5. Plus 2, 2 is 10 over 5, so that's 16 over 5. That's one of the possible ones. Or, if lambda equals to minus 2/5, we've got E, I won't bother calling it E dash now, E equals 2, put in minus 2/5 in there, minus 2/5 times minus 5 is equal to plus 2, so that will give me 3. Minus 2/5 times 4 is minus 8/5. Take away 5, take away that number is 15 to 8, 17/5. And then minus 2/5 in here. 3 times minus 2/5 is minus 6/5. Plus 2, which gives me 4/5. I think that was about the hardest bit of the paper. Fairly high boundaries for this paper. Bit of a shame can't get that at 5 marks, because I think the A star depended on at least getting some marks of that and not getting much of the rest. Wrong for those of you going for A stars or high grades. Okay, so that's C4 done, and I hope you found it useful. Okay, if there's any questions, do feel free to put a question below. I may, if I have time, answer such questions. Thank you very much. Bye.